Welcome to myprojectbazaar.com. Let we discuss about the process segmentation driven image registration application to 4D DCE-MRI recordings of the moving kidneys. Let me see the abstract of the process. Segmentation of the images refers to extracting the needed regions from the images based on some specified methodologies. The segmentation methodologies were commonly based on thresholding, that is, the regions within the particular range or pixels that were having particular values. Edge detection, contour extraction, clusterings were all common segmentation methodologies. Edge detection identifies edge points around the needing objects. Contour extraction refers to outlining the segmentation portion from the images. Clustering refers to the production of separate identifications, color, contour differences for the regions in the images that are similar in intensity or similar in color. Abdominal MRI has kidney along with other abdominal parts in the images. The segmentation of the kidney alone from the MRI images will be useful for the identification of defects in kidneys. The 2D MRI scan of the abdominal images were taken. Basic pre-processing steps like gray conversion, resizing and smoothing using filters were applied. This process makes the image pixels to have the same sequences of values. The pre-processed images were then segmented by using registration process. Several images containing kidney locations in the different positions were used for the training process. The training process registers the shape of the kidney in different positions. For different positions and intensity of the kidney, the positions and the coordinations of the kidney locations in the images were identified. The kidney in the test image is segmented by comparing the shapes in the images with the registered shapes from the dataset. For matching the kidney, the mean value of the images were employed. The calculation of the mean value of the images will give the information regarding the intensity of the images. The matching processes compares the intensity selected, the kidney portion that is extracted from the images. This process is done with the help of active contour methodology. The shape in the dataset that is matching with the input test image is identified with the help of distance calculations. The distance will be minimum for most matching kidney portion in the images. The disease in the kidney images were identified based on the features extracted from the images based on statistical parameters. The extracted parameters for the processes were classified based on adaptive neuropathy interface system. The performances of the process is measured in terms of accuracy, sensitivity and specificity of the process. Let me see the flow of the process. The input abdominal scan is obtained. So this contains the normal 2D MRI images. The obtained images were pre-processed. After the pre-processing step, we train the data images in the datasets that we have given by saving the shapes of the kidney locations in all the images in the dataset. This process is the registration process. So while we have trained the database and the registered portions were saved, we calculate the distance between the extracted mean values, and based on that the image with minimum value is the matching value. That is, we have calculated the mean value for all the images in the dataset and we have saved it previously. So we calculate the mean value for the input image and the differences between them is calculated, and based on the matching processes the exact registered kidney shape with which the input image is matched is got. After the matching, the kidney coregion coordinates were obtained, and based on that the kidney portions were extracted from the dataset, were extracted from the input image that we have given. So this, for this extraction of the model, the active contour segmentation is employed. The registered portion is applied to the input image, and the registered and the matching shapes corresponding to the input images were got. The matching shapes here defines the positions and the locations of the matching portions in the original image. After the matching of them, the active counter segmentation is employed. The active counter segmentation grows the regions based on the intensity ranges and stops when the overall intensity is similar. So for the active contour, the input shapes will be the registered shapes given in the process. After the segmentation, we extract the features from the images based on area, length, height, entropy, mean, standard deviation values extracted. The features extracted based on the input processes is area, length, height, entropy, mean and standard deviation. These extracted statistical values along with the other values were calculated and they were given as input for the adaptive neurophagy interface system. So this classifier classifies the images to normal, moderate and severe categories. Thus we have segmented the kidney portions from the images and we have analyzed the overall defects in the locations. Let me see the running procedure of the process. If you want to run the code, select the file main.m which is located in the source code folder. Right click it and click on run file. The process will get started. So this user interface contains the menus and the display accesses for the execution of the process. So select any one of the two images present in the dataset. We have implemented the process for the images in the datasets alone. It is a training process and hence the process will execute for the images in the datasets alone. After that, the pre-processing step is employed. Then shape matching is employed and the shapes of the input regions were extracted, and after that the kidney detection is employed. For this the active contour segmentation is employed. This process goes on in iterations. After the segmentation of the tumorous portions, after the completion of the completion of the iterations, the tumor portions were segmented and they were displayed as the tumor as the regions in the images alone. After that, the 3D viewing of the images were done in the segmentation process. So the detected kidney regions were viewed in 3D. So after this processes, the features were extracted from the images. For the extraction of the features, we use area, x and y coordinates, height and width, centroid positions, diameters and perimeters. These were all extracted for the left kidney and the right kidney, and after that the classification of the processes employed. So this process denotes the classification model. So if we obtain the severely affected kidney means kidney failure, immediate medical attention needed, so this result will be displayed. Then this is obtained based on the adaptive neurophagy interface system. The performance of the process is measured with the help of accuracy and the error rate. So as we can see, the accuracy value and error rate value were obtained and they were depicted in the graphical format comparing with the existing methodologies. Thus we have segmented the kidney portions and we have analyzed the diseases in the kidney regions, and the overall performances of the processes were measured in terms of accuracy, sensitivity and specificity. Thank you.